Hello, good afternoon, everyone. So this time we're going to discuss about line integrals. This is the first lecture on finals. So for the finals, we will also discuss double integrals in Cartesian coordinates, center of mass, and moments of inertia. Masyadong mabilis yung, let me just, okay, have this one. Our intended learning outcome will be about, of course, your line integrals and multiple integrals. Take a look here. We define your line integral to be this one, that is the common notation is this is the integral of m of xy dx plus n of xy dy along this curve. Note that your work is defined as the integral from a to b of the function, this is of course function times r prime of t dt. Take the first example here. Suppose there's an object that moves along this parabola. This parabola is a parabola which opens upward from the point -1, 1 to this point 2, 4. We are to find the total work done if this motion is caused by this force field. X squared plus y squared I plus the x squared yg. We will assume that the arc is measured in inches and the force is measured in pounds. Now the plane curve, take a look here, the plane curve is given by r of t ti plus t squared j for t within the given interval -1 to 2. And notice that the curve here, the upper curve is the parabola which opens upward from -1 to 1 to 2, 4, meaning to say the domain here, -1, and you have the up to your x here is equal to positive 2. So if we parameterize that one, we have x equal to t and y is equal to t squared from -1 to 2 value of your t. And here, because f of t, I plus c of tj is your r of t, or where f of t is your t, and g of t is your t squared, we have r of t therefore is ti and plus t squared j. And your f of t, g of t, t squared, and your f of xy, x squared plus y squared, to x squared y are the components. So that f of t is f of t squared. You can again replace your x squared there to be your t squared, y squared will be your t to the fourth, whereas y is t squared already. So when you square that, you come up with t to the fourth. These three x squared, so the ct squared since our y is t squared, so 3t squared times t squared will give us 3t to the fourth. Recall that this is our formula for work, f of t, g of t, r prime t dt. And we just simply come up with f of t squared, r prime t dt, but this is, remember that it's from -1 to 2. So that r prime t is 1 and 2t, and this one is t squared plus t to the fourth. Why 1 and 2t? Remember that r of t is this, t I t squared. So the derivative of this is 1 and the derivative of this one is 2t. So you have 1. That's why you have 1, 2t here. Then Negative 1 to 2 t squared plus t to the fourth 6t to the fifth dt. Why? Because this is, you can, when you take the dot product, it becomes t squared plus t fourth. Okay. Plus, we have to multiply 3t to the fourth times 2t, which is 6t to the fifth. That's your dot product. And because of that, we have here, we evaluate this becomes t cubed over 3 plus t to the 5 over 5, 6t to the 6 over 6, but it cancels out. So you simply have the following: t cubed over 3 plus t to the 5 over 5, t to the 6, evaluated from negative 1 to 2. Now, upper limit minus the lower limit. That means to say it's 2 to the third power over 3, 2 to the 5 over 5, then 2 to the 6. Then minus negative 1 to the 3 over 3 plus negative 1 to the 5 over 5 plus negative 1 to the 6. But that should give us the following: 8. When you rate that to 2, that becomes 8 over 3 to the fifth. 2 is 32 over 5. And this is 2 to the 6 would give you 64. Minus, kanina, this was, uh, we had mentioned this is negative 1 over 3. This one, negative 1 pa rin over 5. And this one, because that's to the 6, it's even. It becomes plus 1. I'll give you a few seconds to compute for that one. So what would be the value now in inch pound? Solving for that should give you 363 over 5, and that should be in inch pound. Now, if m and n are continuous function of xy on this open list, and if we let c be equal to r of t, f of ti plus g of tj be a plane curve lying inside B such that your first derivative and sec of f and the first derivative of g are continuous in AB, the line integral of this mxy dx plus nxy dy over c is given by the following. It's the integral over this curve. And the integral, this is the same as the integral from a to b of m of ft gt. Take the first derivative of f here from your r of t. So mean to say take the r prime of t so that you can get your f from t plus n of f of t g of t, which is a function in terms of t. X is in terms of t, function in t, and g prime of t is again from here at 1. So derivative of g of t when you take the derivative of r of t. Or that is the same as you simply take m of f of t g of t and g of t, and you have f prime of t g prime of t. So that product with it. So for example, we have the integral of x squared plus xy dx plus y squared minus xy dy over the plane curve C consisting of the line y is equal to x. So y is equal to x from the origin to the point 2, 2. How does it look like? Y is equal to x is a line which slants with this your x and y axis, this line upward to the right. So it says from the origin to mean to say from this point 0, 0 to the point 2, 2. So you count 2 units, then 2 units here. So this point. And let us take a look at the curve. So the curve looks like this one. The point 0, 0 to the point, this is x is 2, y is 2, 2, 2. So r of t is ti plus tj, wherein your t belongs to the from 0 to here, 0 to 2. if we try to write your r prime t, that becomes plus j. I plus j. And your function x squared plus xy dx y squared minus xy dy can be rewritten as your x squared is t squared, x is t, so t times another t, so you have t squared. Your dx, that's 1 here, and our dy here is 1 also. Y squared can be written as t squared minus xy, so minus t times